Members, let's just represent our answer now. So we have earlier on discussed and we have derived the numbers. The most significant bit is on position number. This is 9, and where we have 128, and this is the least significant bit. But then we find that we cannot express 192 from 64 and moving onwards. So 128 has to be inclusive, but then we need 8 bits. So since we need 8 bits, the least significant binary bits, the zeros are omitted. So what does it mean? Our IP address of 192.168.16.100 will be, we said it is going to be, let me just write it finally. Let me rub this and write how our IP address would look like. So we have 1, 1, and the rest are zeros. So 0, 0, 0. Then we put a dot. We got 168. So we will have 1, 0, 1, 0, 1. The rest will be zeros. So we will need 1, 2, 3, 4, 5. We will need 3 zeros. Then we go to the next. The next is 16. 16 will have 0, 0, 0, 1. And this is 0, 0. So we need to omit the last how many zeros. So we have 1, 2, 3, 4, 5, 6, 7, 8. We omit the last one. So we have 0, 0, 0, 1, then 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. We add another 0. Then we put 100. Okay. When we put 100, what will that be? It will be 0, 1, 1, and that will be 0, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 192. 168, we have 16, and we have 100. So the IP address that we would need when we have 192.168.100, a conversion would look like that. Now, members, let us just look at how we can convert the decimal to binary, maybe using a code. We can write a simple code. So we are going to do what we call a flow chart. A flow chart. We need the flow chart. Just to help us, this is a flow chart that I'm talking about. So we will first of all start, and we have not seen how to convert to the rest from decimal to the others, the octal and the hexadecimal, but we are going to write a code that is going to help us to convert from decimal to binary to octal and hexadecimal. So we wanted to read the decimal number. Then we need now a function. We need a function that is responsible for octal, for hexa, and for binary. Then from there, we can read our results. We will see our output, and there we will stop. So how are we going to do that? I'll just go to Python and create another file that we are going to call maybe number system, maybe conversion. Then we want it to be a .py because we are using Python. So, and then we have several ways of how we can do this, but I'm going to create a function using a diff. I define my function, which is going to be, I'm going to convert octal. Okay, I'm going to have my decimal to octal, to hexadecimal, then to binary. But then it takes the argument, it takes a decimal number as an argument, or it is going to be a function of a decimal number. Let me number. So I need to define what I need here. I need first of all an octal representation, and I'm going to use an inbuilt function of oct. So oct of the decimal number. Let me copy this for me to be faster. Let me copy this. I paste it there. I paste it there. So here I'm going to call this hexadecimal representation. Then the function, the inbuilt function from Python I'm going to use is called hex. It takes the hexadecimal of that binary number. Then I also have the binary representation. Then it takes binary, so I use bin, which is an inbuilt function. Okay, so now we need to, getting these functions, then what else do we need? We need to find a way how we are going to have an input and also displaying the results. So I'm going to say my decimal number is going to be an integer, and I use an input function that helps us to put in any values, and this is going to be a string. So I'm going to say enter the decimal number. So when we put in our decimal number, we find that we need at the end of the day to get octal, then hexadecimal. That will be the output, hexadecimal, then the binary. And this is going to equal to, we are going to call this function. We are going to use this function to be the one to help us compute these results that we need here. But then what do we need to return? Because this defining the function, you need to return something. So you need to return these ones, because these are the answers that you need to return. I need to return the octal representation, the hexadecimal representation, and the binary representation. Let me paste them here. But these ones are not there. Let me delete this. So I only need a comma there. Then this one also I need to delete. Okay, I need to use the right indentation. Then I come here, I say I want to print now. I want to print these results, the hexadecimal, the octal representation, because those are my outputs. But I'm going to use what we call formatted string literal. So I'm going to say print f. I'm creating now a string. So I'm going to put in my octal representation. But in that octal representation, I need to put in a space holder. So my space holder for that, since I want the octal representation, it is going to be now the output that is stored in this variable octal. So I'm going to put octal. Okay. Let me see. This is okay. Okay, let me pick this one. I also put that, but then here I want hexadecimal. I want hexadecimal. Okay, hexadecimal. Then here I want binary. As already identified up there, so the indentation is within this function that I have defined. So let's quickly go through. We have said we are defining a function that accepts the decimal number as an input. Then that function must convert the decimal number to octal. It must also convert it to hexadecimal. It must also convert it to binary by using now the following functions: the oct, which is present, as you can see. Then the hex is also a function in inbuilt in Python to convert the decimal to hexadecimal. Then the bin, which means we are converting to binary. And then we must return the output. So the output of this function is always going to be the octal representation and the rest. Then we need to define how we are going to tell the user to put in. So we have used the int because we are putting in an integer, no decimal, meaning in case we put in a decimal value, then it is not going to work. So for simplicity, we are beginning with that. Then we print our values. It is going to print the octal, the hexadecimal, the binary based on the decimal number we have put. So let's run. I'm going to run the Python code. So we are here. So we want to run the code, but usually there is always that translation from one form to the other. But Python being high level, it only does it does, of course, line by line, and that's why they always waste time, not like the C. So I'm trying to let us see if there is maybe any issue within our code. Okay, let's save. Okay, I don't know why it is slow, but okay, let's move this out and also this. Also move. This is octo. Also move this. Also move this. Also move this. Then we put this one inside. Okay, so now this function is working when we define it, the value, it is going to run through up to this return. So it is this return that helps us to give the output. So based on the rest of the playing with the code, we are doing it outside this other function. So let us see, maybe run and we see. So now it is accepting. So let us put 192. Sorry. So we are putting it at the terminal here, 192. So 192, it is also giving us the values OB110000. So sorry, we did not edit here. So let us edit this as binary representation. Then this was hexadecimal. So we save. Let me first clear what is here. Then we do the running. So when we run, we are going to put, said we want 192. So when we put 192, our result is this. So let's go to where we had our calculations. We want to see whether it resembles this. So let's put it somewhere here. So from Python, this prefix OB is just telling us that it is binary, so you read your values beginning from here. So let us see. Maybe we change the formatting. So we have something like this. These are how many? 1, 2, 3, 4, 5, 6, 7, 8. Let's go to what we have here. It also starts with 1, 1, and then 1, 2, 3, 4, 5, 6. So it means we are right. We are very right. Let's put 1. This is from Python. From Python. This was for 192. So let us check if we put, of course, now the rest, this hex, this OX means hex. So maybe let me copy all of this. So this is the octal of 192. You can go and try it out. This is hexadecimal. Can go kind and try it. The prefix, these first ones, this is the one showing this prefix OX represents hexadecimal. Okay, so this is Python value. So these are values from Python. Also, this means this O at the beginning. This means octal. This is how Python is representing it. So, meaning the 300 itself is the digit that is, we are saying 300. This is octal. It should equal to 192 in what? In decimal. Then we are also saying C note, CO is what we are saying is what? Is 192. This is hexa and this is in decimal. So maybe let's run it again and put in we just test it for the last two. Maybe let's put in 168 and see. So 168, so when we bring it here, so 168 would give us these values. So you can confirm. You remember we had this value from up here. We have 10101, the rest are zeros. 10101, the rest are zeros. So we are right. Let us put in, we run it again. Okay. We can put in 16. We are putting in 10. So if we put in 16, so the binary number that we calculated also had 1 and 4 zeros according to what we have up here. We had the 1 and 4 zeros. So meaning we are right. So let us put in the last one, which is 100. So Control Alt N, we run. So when we run here, we can put 100 and it gives us the value that we are looking at. So these are our values. So if we check up here, we have 11001, 11001, and the rest are zeros. So we can see that these are Python answers and we are correct. So members, that's how we can do it. Maybe I don't know if I should copy this code and also include it here so that whoever will receive this document can go and try it. So maybe what I need to do, I need to define, I need to say code designs a function that accepts a decimal number and converts it to octal, hexadecimal, and binary number systems. So members, I think we can stop here, except if there is any question.
Yes, we are on. We are on.
If there is any question, I think we can stop from here and add on next time.
Is Sarah still there?